Welcome to this fourth video of real numbers of standard 9. In our previous videos, we have recalled what are the rational numbers and how it can be expressed. Rational numbers can be expressed in the form of either P upon Q form, that is vulgar fraction, or it can be expressed in the decimal fraction 0.35 or 2.47, etc. like this. This is called as decimal fraction. Now, as these rational numbers are represented as a part of division P upon Q, the set of rational numbers is denoted by the letter Q. Q stands for quotient. And Q stands for quotient. This is a quotient of P divided by Q. And that's why that set is shown by the letter Q. And R is the letter used for the real numbers. Okay, when it is vulgar fraction, it is P upon Q form. That P and Q both are integers and Q is not equal to 0. And when we try to write the denominator Q as a positive natural number. We try to write, if it is negative, it is not wrong, but by convention we write Q as a positive number, okay, positive natural number, or we can say positive number or natural number. We write it in this way. Now, and one more thing we have seen in previous video, that the decimal form of rational number is either terminating or it is non-terminating but recurring. That we have seen in the previous video. Now we are going to study about what are the irrational numbers. Even we have learned something about irrational numbers also in the previous classes. That when the decimal form is non-terminating, non-recurring, we call them, they are irrational numbers. They are irrational numbers. When it is non-terminating but recurring, they are rational. But when it is non-terminating, non-recurring, they are irrational. Now, what type of numbers do we find? So, we can say that the square roots of non-perfect squares are as irrational numbers. Means 1, 4, 9, 16 are the perfect square. Their square roots are rational numbers. Square root of 1 is 1, square root of 4 is 2, square root of 9 is 3. They are rational. But what about the numbers in between? Now, 2, 3, they are not perfect squares. So, square root of 2, square root of 3 is not a rational number. We have learned how to find the square root of these numbers using division method. And in that division method, we get its decimal form in this form, non-terminating, non-recurring. Means the division process doesn't end, so it is non-terminating. And after the decimal point, we do not get same group again and again. It means it is non-terminating. So we have learned that this square root of 2, square root of 3, square root of 5, square root of 6, they are irrational numbers. And we also have learned how to plot them on the number line. Okay, as this numbers can be plotted on the number line, they are real numbers. They exist in reality, and that's why, though they are not rational, they are irrational, but still they are real. So, the irrational numbers which are not rational but real. Now, in this video, we are going to learn about how to prove the square root of 2, square root of 3, like these numbers, it is an irrational number. Now, for writing this proof, we are going to use the method which is called as indirect method. The statement which we cannot prove by normal direct method are used to solve in indirect method. In this method, what is done, that whatever we have to prove, that we assume that is wrong, and we assume its converse to be true. Means when we have to prove that it is a rational number, we will assume that it is a rational number. Okay, which we know that it is false, but we will assume that square root of 2 is a rational number, and we only will try to show that this statement, whatever we have assumed that it is rational, it is false because it contradicts with certain situations, certain thing which should not happen, and then we prove that our assumption is wrong, and that's why it is irrational. Let's see. I can give one simple example to you. Suppose we know that 6, 7, 8 are consecutive natural numbers. Okay, and if you want to prove that 6 is a consecutive natural number of 5, after 5, 6 will come. How can we prove that 6 is a consecutive natural number? Now, if you want to prove that 6 is a consecutive natural number, suppose we take that, let's say 6 is not a consecutive natural number. Then we can say that let's 7 is a consecutive natural number of 5. Okay. But if 7 is consecutive natural number of 5, what is the difference of 7 and 5? Difference between 7 and 5 is 2. But we know the fact that difference between two consecutive natural number is 1. Now this is contradictory with the fact that their difference is 2 here. It should be 1. This contradicts with the fact. Why it is contradictory? With then our assumption that 6 is not a consecutive number is wrong, and that's why 6 is a consecutive natural number of 5. So this is a simple example just to understand what we do in our indirect method of proof. Okay, so now let's see how to prove this proof part. Now to prove that square root of 2 is an irrational number, we will start our solution or answer like, let's assume that square root of 2 is a rational number. Okay. Now if it is a rational number, we should be able to express square root of 2 in the p upon q form. Therefore, let square root of 2 is equal to p upon q, where p and q are co-prime integers. Co-prime integers, and q is not equal to 0. Okay, this is we have written with the help of the definition of rational numbers, which we have seen in the previous video. If you have not watched that previous video, you can watch it. Its link is given in the description box. Okay. Or now, what is the meaning of the co-prime integers? First of all, they are integers. Co-prime means they do not have common factor other than 1. Okay, this is called co-prime integers. Okay, so if root 2 up is equal to p upon q, then we can take q here. So it is q multiplied by root 2 is equal to p. It means p is what? Q into root 2. So we got this value of p in terms of this. Now if we square both the terms, what will happen? So if we square this, p square is equal to q into root 2 the whole square. Therefore p square is equal to q square into square root of 2 the whole square is 2. Simple. It means p square has two factors. First factor is q square and the other factor is 2. Okay. So from this we can say that, therefore we can say 2 is a factor of p square. Okay. So it means when p square is written in the form of product of these two. For example, if I say 15, if it is in as 3 5s are 15, or if it is say 14, it is 2 7s are 14. These are the factors. 3 is a factor of 15. We can divide 15 by 3 to get the remainder as 0. Or 15 is divisible by 5. That means 5 is also a factor. So when we write any particular number in the form of product, these are the factors of the given numbers. Like that, if when we have written p square is equal to q square into 2, so 2 is a factor of p square. Okay. Now if 2 is a factor of p square, 2 should be the factor of p also. Okay. Because what is p square? P square means p into p. Okay. So if 2 is a factor of this, whenever we have square, that's for example, if it is we are taking 6, what is 6 square? It is 36. Now if I can, 36 is written as 2 into what? 2 18s are. So if 2 is a factor of 36, and we can write 6 as 2 3s are, correct? So 2 is a factor of 6 also. So if 2 is a factor of p square, p is a factor of 2 is a factor of p square, 2 is a factor of p also. So from this we can write, therefore 2 is a factor of p. because p square is what? T into p. So here if it is going to be factor, so 36 is what? 6 into 6. You can understand like this also. So it is 2 into 3, 2 into 3. So if 2 is a factor of 36, 2 is a factor of 6 also. Means if 2 is a factor of p square, 2 is a factor of p also. Okay. So we have proved that 2 is a factor of p. Like that, we will try to prove that 2 is a factor of q also. How to prove? Let's see. Okay. Now if it is a factor of p, therefore we can write p is equal to 2 times certain number. If 2 is a factor of p, we can write p is equal to 2 times certain number. That certain number we can assume as a variable t. So let's take p is equal to 2 times t. Okay. Therefore, if we square both sides, we will get p square is equal to 2t square. And therefore, p square is equal to 4t square. Okay. Now here we have value of p square as 2q square. Let's take 1. And here we take, let's take 2. Okay. In both cases, we have p square. Here it is 2q square. Here p square is equal to 4t square. So from one end to what you can say that 2q square is equal to 4t square. This is from 1 and 2. Okay. So here p square is equal to 2q square and here it is p square is equal to 4t square. So this 2q square and 4t square are equal. From this, let's get value of q square. So q square is equal to 4 upon 2. It will divide it by 2. You will get it 2 times t square. Okay. Now here we can see that q square is product of 2 into t square. It means 2 is a factor of q square. 2 times t square. So it is factor of q square. And if 2 is a factor of q square, it should be factor of, therefore 2 is a factor of q also. Okay. Now let's take this statement as 3 and this statement as 4. So what does 3 and 4 tells? 2 is a factor of p as well as 2 is a factor of q. Now this is contrast, so we can say that therefore from 3 and 4, so 2 is a factor of p and q both, correct? But here what we have written that p and q are co-prime integers. When it is co-prime, it means that they do not have common factor other than 1. And here what did we get? We got 2 is a factor. So we can write which is contradictory, means not matching, contradictory, that p and q are co-primes, okay, co-prime integers. So as it is we have got contradictory, so we can write that our assumption is wrong, therefore our assumption is wrong. What is our assumption? That square root of 2 is a rational number. This is wrong, and that's why it is wrong. If it is not rational, it should be irrational, and therefore square root of 2 is an irrational number. So like this we have proved that square root of 2 is a rational number. Like this you can prove square root of 3, 7 also irrational number. Only wherever it is 2, you have to just put that 3, and if it is square root of 3, if you have to prove square root of 5 to be irrational, there you need to put square root of 5. The rest part will be as it is. Only this two number will be replaced by 3 or 5 or so on. In this way, you can prove that these irrational numbers are really irrational. So this is the way to write the indirect proof. My dear students, this part I know that it is complicated, but I have tried to make it as easier as possible. You practice this. If you practice this 2-3 times, I'm sure that you can write this proof independently by your own. Thank you very much.